Hello viewers, welcome to the video lecture series on data communication. It is the first lecture of the 40 lecture series, and in this lecture I shall give an introduction and course outline. First, let me introduce myself. My name is Ajit Pal. I joined IIT Kharagpur in 1982, the day Asiad started in Delhi, and I am currently professor in the Computer Science and Engineering department of IIT Kharagpur. I received MTech and PhD degrees from the Institute of Radiophysics and Electronics, Calcutta University in the year 1971 and 1976 respectively. My research interests include embedded systems, low power VLSI circuits and computer networks. I am fellow of the IIT India and senior member of the IEEE USA. If you want to send email address to me, here is the email address apal@cac.iitkgp.ernet.in. So, you can send email to me on this. Before I discuss about the various topics that will be covered in this lecture, first I shall give a very oversimplified model of data communication system, and that will put you in proper perspective. So, here is the oversimplified model of data communication system. You have got a source. Source is essentially where the data is originated. Source can be a computer, peripheral, it can be some communication equipment like cell phones, PDAs and so on. So, any system which can send data, which can process data and which can receive data can be source. Then you will require a transmitter. Then you will require a transmitter, and transmitter is the device which converts the data sent by the source into a suitable form for transmission through the medium. As we shall see, the source generates data and transmitter will convert it into a suitable form which can be sent through the communication system. So, the third component is the communication system, the medium through which signal is sent. Now, the medium can be very simple, a piece of wire or a pair of wire like coaxial cable, twisted pair of wire, or it can be optical fiber, or it can be local area network, it can be wide area network. So, by communication system we mean that it can be very simple system like a pair of wire, or it can be very complex system like LAN, WAN or internet. So, we shall consider different types of communication systems. Then comes the receiver, which receives the signal and converts it into data or message. So, here again you see you require a receiver which will receive the signal coming through the communication system, and then it will do some processing, and then it will send after converting the signal into data, it will send to the destination. Destination again can be a computer, can be peripherals, can be communication equipments, whatever source and destination equipments can be of same type. Now, let us consider what do we mean by data. The source is generating some data or message is the information to be communicated. What do you mean by data? Data is something which conveys some meaning to the receiver, that is what we call data. And data can be analog in nature, can be digital in nature, or and so here by DT we means the data, it can be analog, it can be digital, which is sent from the source to the transmitter. Now, the transmitter, as I said, will convert it into a signal. So, data is transformed into signal. As such, the data cannot be sent through the communication system. Data has to be converted into some electromagnetic signal which can be transmitted through a medium. This signal can be electrical in nature, electronic in nature or optical in nature, which can be sent through the communication system. And then let us see first, before I discuss anything else about the communication system and other thing, let us first consider what do we mean by data and signal. First of all, we shall discuss about what do we mean by data, analog and digital data types, analog and digital data. Then as I mentioned, the data has to be converted into signal. Again, the signal can be analog or digital in nature or digital. It can be either of the two types. So, we shall discuss about two different types of signals, analog and digital. Both types will be considered, and as we shall see, the signal can be periodic in nature, can be aperiodic in nature, and in fact, a signal which is not periodic in nature can be considered as a combination of some periodic signals. So, we shall first discuss the periodic signal characteristics and then we shall see how periodic signals can be used to form non-periodic signals. And as we shall see, the signal can have two different types of representation. One is time domain representation, another is frequency domain representation. We shall discuss about the time domain and frequency domain representations, and in this context we have to discuss the spectrum of the signal and bandwidth of the signal. We shall discuss about both of them and we will also see the relationship between the two. And obviously, when a signal is generated, it has to be propagated and obviously for going to whenever it goes from say transmitter to the receiver, the signal has to go through the communication system, and depending on the distance and medium used, there will be some propagation time, and obviously the wavelength of the signals that can be sent will depend on the medium that is being sent. So, we shall discuss in details the data and signal. Then comes the impairments that take place as the signal goes to through the signal. As the signal passes through the transmission media, it suffers some impairment. That impairment can be in the form of attenuation. We shall see how attenuation occurs, and also the unit of attenuation, decibel or dB, which is universally used. We shall discuss about the attenuation of different types of media and the unit of attenuation. And also in this context, we shall consider the bandwidth of a medium, the signals which can be sent through the medium, and for different types of mediums the signal can be of different types. Then as I said, the impairments will take place, and one reason is attenuation and second reason is distortion. The distortion will occur in two forms. These two forms are known as delay distortion and also the time distortion, and obviously these two distortions ought to be taken care of at the receiving end. And the rate at which the data can be sent will be dependent on the medium, and as we shall see, there is some limit, data rate limit, which can be sent through a medium and which is characterized by Nyquist bit rate. Depending on the bandwidth of the medium, the Nyquist bit rate will be decided. We shall discuss in detail about this Nyquist bit rate, which is the highest data rate that can be transmitted through the medium. And another important concept is the baud rate. We shall see as the data is sent, it is converted into signal, and actually the rate at which data is sent and the rate at which the signal elements are sent through the medium is different, and that leads to two different concepts like bit rate and baud rate. We shall discuss about both of them in details and the relationship between the two. And apart from attenuation, distortion, there is another source of noise the noise, the another source of distortion is noise. We shall discuss about various noise sources and see how they affect both the analog and digital type of signal. As we say, as we know, the signal can be analog in nature or it can be digital in nature. So, how these two different types of signals are affected as because of noise, and whenever in presence of noise, how the bandwidth of the signal or the rate channel capacity changes, that is decided by the Shannon capacity in a noisy channel. We shall discuss about this in detail in subsequent lectures. Then as I said, the signal has to be sent through some transmission media. We shall discuss about two different types of transmission media. In fact, the transmission media can be broadly divided into two types. One is guided, another is unguided. In case of guided transmission media, there are three popular types: twisted pair, coaxial cable and fiber optic cable. We shall discuss about the characteristics of these three types of guided transmission media, and also we shall discuss about the transmission of signal through unguided media or through air. In that case, of course, as we shall see, there are three mechanisms of sending transmission in the wireless form. One is radio wave, another is microwave, another is infrared. So, there are three different forms in which the wireless transmission occurs, and the example is the broadcast radio, that AM FM radio that we hear, then the terrestrial microwave, satellite microwave and infrared communication. So, these are the four different types of transmission media in the context of wireless communication, and we shall discuss about all of them in details. Then as I said, the signal has to be, data has to be converted into signal for transmission through the media, transmission media, and depending on the data and the signal, as you can see, various approaches that can be used. First of all, if the data is digital in nature, here the data is digital in nature, signal can be also of digital in nature, and in that context we call it encoding. Whenever we transform digital data to digital signal, the approach that is followed is known as encoding, and as we shall see, there are various encoding techniques. Then if the data is analog in nature, such as voice, video, and convert into digital form, then also we have to do encoding. So, in general, whenever the signal is digital in nature or when we do digital transmission, the conversion process is known as encoding. On the other hand, whenever the signal is analog in nature, whether it is an analog data or digital data, we call it modulation. That means the technique is known as modulation. And obviously, what type of signal should we use will be dependent on the situation and bandwidth and obviously of the transmission media that we are using. Let us look at the conversion techniques, coding techniques first. Here we have mentioned mentioned about the various techniques for digital to digital conversion. That means, here we are doing encoding. The encoding can be divided into three types. This is known as line encoding. So, unipolar, polar and bipolar. Unipolar is not that popular. So, it is not popular because of its various limitations, and we shall discuss about the limitations of unipolar transmission. And the polar, where the signal has two different levels, has got a number of varieties such as non-return to zero, NRZ, return to zero, RZ, Manchester encoding, differential Manchester encoding. So, these are the four popular polar techniques for line coding, and we shall discuss about each of them, their advantages, disadvantages, bandwidth required in details in the subsequent lectures. So far as the bipolar techniques are concerned, which have some advantages, are AMI, amplitude Mach inversion, then B8 ZS and HDB3. So, these are the three popular bipolar encoding techniques, and we shall discuss about these three techniques in details. Coming to analog data to digital signals, where the data is say analog in nature, such as voice, video. In such a case, you have to convert the analog data into digital form, and there are two basic approaches known as, one is known as pulse code modulation and second one is known as delta modulation. So, we shall discuss about these two techniques, and obviously, we shall consider the limitations of both PCM and delta modulation technique and compare these two approaches in details in subsequent lectures. Coming to the modulation techniques, where we are generating analog signal, and if the data is analog in nature, we have three different modulation techniques, which can be broadly divided into two types: amplitude modulation and angle modulation. And again, angle modulation has got two different components: frequency modulation and phase modulation. Actually, when we shall discuss the data and signal, we shall see that an analog signal has got three important parameters: amplitude, frequency and phase, and any one of the three parameters can be modified or changed to send embed some signal, and actually this has led to three different modulation techniques like amplitude modulation, frequency modulation and phase modulation, and we shall discuss about these three modulation technique in details, their advantages, disadvantages, the bandwidth required for transmission through the media, the immunity to noise and so on. We shall discuss about the three modulation techniques. Coming to digital to analog modulation, where the data is digital in nature and signal is again analog in form. So, in such a case, again we have got three different techniques known as amplitude shift keying, frequency shift keying and phase shift keying, and of course, these two can be combined to form another modulation technique known as QAM, quadrature amplitude modulation. So, we shall discuss about these four modulation techniques which are used for converting digital data to analog signal, and these are widely used, particularly the QAM and PSK are used in many applications. ASK is used in amplitude in transmission of signal through optical fiber. So, all these modulation techniques we shall consider in details. Then as we shall see, whenever the bandwidth of the medium is very high, it is possible to send several signals simultaneously, and the technique that can be used is known as multiplexing. And in this lecture, we shall discuss about the basic concepts of multiplexing, and there are two different forms like frequency division multiplexing and wavelength division multiplexing, rather three different forms: frequency division, wavelength division. These two are essentially same thing, represented in two different ways. And then time division multiplexing, again time division multiplexing has got two different forms: synchronous TDM and asynchronous TDM. We shall discuss about both of them and compare their advantages and limitations. And as we shall see, nowadays another technique that is being used is known as inverse TDM. So, when we shall discuss multiplexing techniques, we shall discuss all these topics in details. Of course, the multiplexing has got very wide applications, and in this lecture series we shall discuss about four important applications, and four important applications are telephone system, which is used in our day-to-day life, which has gone, and how we shall discuss how using multiplexing technique two different types of services known as analog services and digital services are provided. And nowadays it is possible to have a broadband service using the telephone system known as DSL technology. So, digital subscriber line technology, and it has got three different types of three different variations like ADSL, SDSL and HDSL, rather four different types: ADSL, SDSL, HDSL and VDSL, and we shall discuss about all the four one after the other when we shall discuss the multiplexing application. Then we shall discuss about cable modem, where the standard cable TV network can be used for transmission of data, and that is possible by using a technique known as hybrid fiber coaxial network or HFC network, and we shall see how multiplexing technique is used not only to send the TV signals, but also to send data rather which can be used for internet access. Then so far as the optical network is concerned, we shall consider another important application of multiplexing known as SONET, synchronous optical network, and synchronous optical network provides you very high bandwidth, and we shall see how that bandwidth can be used, and particularly the telephone system and SONET system can be integrated, that also we shall discuss in detail. So, these are the four important applications of multiplexing. We shall discuss in details in subsequent lectures. Now, we have discussed various techniques that is being used for sending signal through the communication system, the encoding techniques, modulation techniques and multiplexing techniques. And as the signal passes through the medium, because of the various impairments, the signal that is being sent, that is ST, is not same as it is received by the receiver. So, signal received through the medium is different from what has been sent, but what the receiver wants is the same thing. Now, so we have to find out what kind of problem or what is the difference between the original signal and the received signal. So, particularly in this context, we shall discuss first about how the interfacing to the medium can be done, and for that purpose the various modes of communication we shall discuss, like parallel and serial, simplex, full duplex and half duplex techniques. There are two approaches of serial communication and also parallel communication, asynchronous and synchronous, we shall discuss about that. Then DC-DC interface, that is being used for interfacing between the source and the transmitter, and also for the destination at the interface. So, this interface is known as, these source and destination are known as the DTE, and data terminal equipment, and transmitter and receiver are known as DCE. So, this interface will be discussed in detail, which is known as RS-230C, and in this context there will be a concept known as null modem that we shall discuss in details. The next .25 and various types of modems or DCEs that is being used will be discussed, so that you can interface to the communication system. So, then we have got another important concept. You see, as we receive the signal, we shall see the data that is being sent by the source is different from the data that is being received. So, they are not same. So, in this context there is some problem, and that problem is known as error. So, because of various types of impairments like attenuation, distortion and noise, there will be error. Error will be introduced in the signal. If it is a digital signal, a 0 will become 1, a 1 will become 0. And obviously, first we shall discuss about different techniques for detection of error, and the various types of error that can occur. First of all, we shall discuss about single bit error, then burst error. In single bit error, only one bit gets changed from 1 to 0 or from 0 to 1. On the other hand, in case of burst error, a sequence of bits, say 1 1 0 0 gets changed to 1 0 1 1. So, this happens whenever a burst error occurs. So, we shall discuss about both of them, and particularly various techniques that is being used for error detection, such as parity check, two-dimensional simple parity check, where only one bit error detection is possible or odd number of error detection is possible. then two dimensional parity check, checksum and cyclic redundancy techniques. So, these are the four different error detection techniques which are used for detecting both single bit error and Basti error will be discussed in detail. And as we shall see, cyclic redundancy check is the most popular, which is known as CRC, and possibly the most widely used technique. And apart from error detection techniques, we shall discuss about error correcting codes, which can be used to correct the error from the received data, and this is known as forward error correction. So, we shall discuss about that particularly by using Hamming code. Hamming code, how error correction can be done. We shall restrict our discussion to only single bit error correction. However, in practice something else is done which is known as error control, and where actually a backward error correction technique is used instead of forward error correction. In backward error correction, what is being done? If the received signal is found to be corrupted, that means if there is error in it, then the receiver sends a message to the transmitter to retransmit the data or message once again. So, it is based on retransmission, and this, for that purpose there are several techniques. And actually, apart from error control, there is another technique which has to be used, which is known as flow control. Flow control is necessary whenever the transmitter and receiver are not of the same capability. Suppose you have got a fast transmitter and a slow receiver, a server and a desktop system. In such a case, the transmitter can send at a very high speed, but the receiver is not capable of receiving at that speed. So, in such a case, there will be overflow, or the buffer of the receiver will become full. So, we have to overcome that problem, and for that purpose flow control technique is used. First technique that we shall discuss is stop and wait flow control, and also sliding window flow control. So, both these techniques will be used, and as we shall see, the performance of sliding window flow control is better, that is why it is widely used. And we shall see that these flow control approaches can be extended to perform error control, or can be used for backward error correction. And for that purpose, the technique is known as ARQ, or automatic repeat request. And there are three different variations of error control techniques. First one is known as stop and wait ARQ, based on stop and wait flow control. So, we shall discuss about the stop and wait flow control in details. Then there is another technique known as go back N ARQ, which is based on sliding window flow control approach. However, here error and lost frame is also taken into consideration. So, we shall discuss about both stop and wait ARQ and go back N ARQ in details. However, go back N ARQ has some extra overhead because of retransmission of some frames which are not really necessary, and that can be overcome by using selective repeat ARQ, and we shall discuss about the selective repeat ARQ and particularly the buffer requirement in both cases, in all the three cases, and also the requirement of the number of bits that is required for numbering the frames. So, frame numbers are to be given, so that this ARQ technique can work. So, number of bits required is again an overhead, that we shall discuss in the context of all these three techniques. Now, whenever we are sending signal through a communication system, it is necessary to have synchronization at three different levels: at the bit level, word level and frame level. So, whenever the data link control is performed, essentially we are interested in frame synchronization. A sequence of bits or sequence of characters are being sent, and obviously in this context you have to identify when a particular frame is starting and when it is ending. So, for that, so to do that you have to use some kind of framing, or a format has to be used, such as it will have some flag at the beginning, then you will have some addresses, then the data, and at the end also there will be some flag, and also it may require some information for flow control, error control. The flow control and error control techniques that is being discussed, how that is being used in data link control will be discussed, and also it will be necessary to perform link management to initiate a link, to continue the communication of messages and terminate the session. So, that is known as link management, and in this context there is a standard which is widely used known as high level data link control, or HDLC. And HDLC is widely used. Not only HDLC is widely used, some limited versions of HDLC in some other forms are also used, and particularly we shall discuss HDLC in details, particularly the following important parameters of HDLC, such as types of stations, data transfer modes, frame formats. All these things we shall consider in detail in the context of HDLC. So, after considering data communication with the help of between two stations, for example, in the previous cases, in case of say HDLC, we are assuming that there are two stations. Here you have got one station, and here you have got another station, and there is a link between them, direct link between them, and they are communicating with each other. That is the case of data link control. But it may be necessary that a large number of stations or equipments wants to communicate with each other. In such a case, this kind of simplified direct link cannot be used, and in such a case we have to go for data communication through wide area network, and in that case we have to use switching techniques. For example, there are different types of switching techniques, and we shall discuss about the techniques like switching techniques like circuit switching, and in one lecture we shall discuss about the circuit switching techniques in details, after introducing the switched communication network. And we shall see in a switched communication network you will have a number of intermediate nodes through which signals are sent. So, you will have some kind of stations, and there is a number of nodes, intermediate nodes, and these are essentially equipments through which are used for communicating data to a number of stations, and stations are connected to such nodes, and that leads to a scenario known as wide area network, because these stations may be located far apart and they are connected with the help of nodes, and in that context there are several switching techniques that is being used, and one of the most popular one is known as circuit switching technique, and we shall discuss about the circuit switching fundamentals, its advantages and disadvantages, and how the circuit switching is implemented. As we shall see, there are different concepts like space division switching using crossbar switches, and time division switching, like say it uses TDM, time division multiplexing, and we shall discuss about how they are combined, space division and time division switching are combined to form a single switching technique. Then you have got, we shall discuss about message switching and packet switching, and in the context of message switching we shall see how a message can be sent through a switched communication network, and what are the limitations of a message switching technique, and particularly as we shall see, whenever a long message, say several gigabytes are sent through a network, it monopolizes the network, it increases the probability of error. As we shall see, whenever a big message is sent, it gets there is a probability of corruption. I mean, probability of corruption increases. That is why message is usually sent in terms of a number of packets. That means, a single message is divided into a number of packets and each of them is sent separately, and that is known as packet switching. And we shall see in that the packet switching is very efficient compared to message switching, and we shall discuss about various packet switching techniques such as virtual circuit packet switching and datagram circuit packet switching, and we shall compare the virtual circuit packet switching and datagram circuit packet switching in details, and we shall see how they compare with each other and what are their advantages and disadvantages. Particularly, as we shall see, the circuit switching is essentially very similar to the telephone network, where you have to establish a link, then do the communication. On the other hand, packet switching is very similar to the postal system, where we can send a letter and drop it in the letter box, and then it can be sent to the next post office and so on. Essentially, it is based on store and forward. Store and forward. So, we shall discuss about these packet switching and circuit switching technique in details, and particularly the application of circuit switching that is being done in say public switch telephone network, PSTN network, where the circuit switching has the biggest application. Then we shall discuss about some important applications of packet switching in different types of networks such as X.25, frame relay, and also in ATM. So, we shall discuss about these three different types of networks where these circuit switching and packet switching concepts are used, and we shall see how data communication can be done through these networks. Then, after discussing the various concepts of wide area network, of course, there will be other techniques which I have not mentioned in the context of wide area network, particularly we shall be having a number of techniques. As I mentioned, frame relay, X.25 ATM we shall consider, and also we shall consider cellular telephone networks and satellite communication. We shall discuss about each of these networks in details and how the various techniques have been used. And in the context of wide area networks, we shall see that apart from switching techniques that I have discussed, we have to use routing, because the message or the packets have to be sent through a number of nodes. So, what will be the route? And we shall discuss about the different types of routing techniques such as fixed routing, and then dynamic routing, flooding, and so on. So, various routing techniques we shall discuss in detail. And in another important concept in this context that we have to discuss is known as congestion. The wide area network can be considered as a network of packets. Now, whenever a large number of packets are sent through the network, a problem known as congestion occurs. Just like on the road, whenever a large number of cars come to the road, traffic congestion occurs. Similar to that, congestion occurs in wide area network whenever a large number of nodes are sending packets, and particularly as we shall see, whenever a large burst of packets are sent, it may lead to congestion, and we shall discuss about various techniques by which we can first of all prevent congestion. So, congestion control can be done in two ways. First, we shall consider how congestion can be prevented, and second technique is whenever congestion occurs, how we can come out of it. So, we shall discuss about both the techniques like congestion prevention and also congestion control, which we have to apply whenever a congestion occurs and we have to come out of that congestion. Then we shall discuss about the various medium access control techniques. Medium access control techniques can be of different types. For example, it can be based on contention based. That means you have got some kind of shared media and a number of nodes are connected, and these nodes are having equal right to access the node. Then all these nodes are contending to get access to the network. So, in such a case we have to use medium access control technique based on contention, and this contention based medium access control techniques has a number of types. For example, it starts with Aloha, which is used in packet radio network. In packet radio network, this is being used. So, we shall discuss about Aloha. Then there will be other techniques which are based on contention, such as CSMA, carrier sense multiple access, which overcomes some of the limitations of Aloha. Then we shall discuss CSMA CD, carrier sense multiple access with collision detection. Particularly it improves the efficiency over CSMA. So, apart from these contention based schemes, we shall also discuss control based schemes, such as which are based on token ring, token bus and token bus and token ring, which is based on sending tokens. That means, whenever a number of nodes are there, a station which is having the token will be able to send. This is how the contention is overcome. So, we shall discuss about these token passing techniques in the context of medium access control, and these token passing control techniques are popular in many applications. For example, in FDDI, an important local area network technique, token passing technique is used for medium access control. So, apart from token passing techniques, the control access techniques, there are other techniques which is based on reservation. There are many applications, particularly which is used in satellite communication. You will see that neither the contention based schemes nor the token passing schemes can be used because of the long delay. So, in such a case we have to use a technique known as reservation scheme. So, we shall discuss about the reservation techniques which is used in satellite communication, and reservation techniques are important whenever the delay is very large, and we shall discuss about the satellite communication, and we shall see how reservation technique is used in satellite communication. On the other hand, the contention based techniques are used in LAN, and also it is being used in cellular telephone system. For example, CDMA, code division multi access, or TDMA, time division multiple access. These techniques are used in cellular telephone systems, and we shall discuss how they are being used. So, we shall see in cellular telephone systems not only multiple multiplexing, but also multiple access techniques are used, and we shall see how they are combined to improve the efficiency of cellular telephone system. So, after discussing the WAN, we shall discuss about the data communication through LAN, local area network. And local area network can be used whenever the geographic region is limited to few kilometers. And we shall discuss various issues involved in local area network. That means, who is sending, what it is sending, and when it is sending. So, this will involve suppose you have got a shared media which is being accessed by a number of users. So, in that case the LAN technique has to decide who will send, what will be sent, that means what will be the size of the packet. As we shall see, there will be some minimum and maximum size, and when it can send, obviously there will be several techniques. We have to use several techniques like medium access control, as I mentioned, particularly in the context of LAN. Both contention based schemes and token passing schemes are used, and we shall discuss how they are used in various local area networks. So, in the context of LAN, we have to use some kind of addressing, so that the sender and transmitter who is sending the packet or frame and where it is going, that means the sender and receiver has to be identified. For that purpose, addressing has to be used. So, the address of the source, address of the destination ought to be sent, that is known as addressing. We have to use error detection in the whenever the data is so in a frame that is being sent, we shall see there will be some address information, source address, destination address apart from data, and also there will be some CRC check for detecting errors. So, error detection that is being used in the context of local area networks. Apart from the conventional legacy LANs like Ethernet, then your token ring or token bus, we shall discuss about high speed LANs, and high speed LANs such as FDDI, fiber distributed digital interface, which is high speed LAN, and also we shall discuss about say fast Ethernet and gigabit Ethernet. Techniques that is being used in high speed LANs. So, FDDI, fast Ethernet, gigabit Ethernet, and what are the advantages and disadvantages. And nowadays, the wireless local area network is becoming very popular. So, we shall discuss about the wireless local area networks such as IEEE 802.11 based techniques, and also we shall discuss about other techniques like Bluetooth that is being used in wireless LAN. So, we shall discuss about the legacy LANs like Ethernet, and also we shall discuss about the high speed LANs and wireless LAN in details. Then as we shall see, apart from local area networks and wide area networks, most of the people are communicating through internet. Data communication is done through internet. So, we shall discuss about the internet, and as we shall see, internet comprises a local area network, wide area network, and they are bound together with the help of suitable software and hardware. So, the basic objective of internet is to connect individual heterogeneous networks, both LAN and WAN, distributed across the world using suitable hardware and software in such a way that it gives the user the illusion of a single network. So, the single virtual network is widely known as internet. So, which is essentially a network of networks. So, question arises, what is the hardware and software that is needed? So, as we shall see here, apart from these hosts, which are essentially the computers, we have got LAN and wide local area network and wide area network, and you see there are other devices which is known as R, essentially they are routers. So, you will require a router, that is the hardware that you require. So, this is the hardware that you require to link the various heterogeneous networks LAN and WAN. We shall discuss about the capability of router and how the routing is done. And also we shall discuss about the software. The software that is being used in this context is known as TCP/IP. So, transmission control protocol and internet protocol, and that is actually the software, and that acts as a glue or which binds the various local area network and wide area network together. So, we shall discuss about the TCP/IP in briefly we shall discuss about it. Then whenever the data communication is done through internet, we have to discuss about a number of techniques such as segmentation and reassembly. A particular packet may not be sent through a particular network because of the restriction on the maximum size. So, it has to be segmented or divided. So, we have to discuss about the segmentation and how the reassembly is done before delivering it to the destination. And also we have to discuss about the encapsulation, how the frames can be encapsulated to send through internet. Then how the connection control is done, how order delivery is performed, how the addressing is done by using that internet address, IP address, and various types of IP addresses that is being used. We shall discuss about that, and how multiplexing is done through a single interface. We can have access to multiple devices, which is known as multiplexing, and how these are all incorporated as part of TCP/IP. We shall also discuss about the data compression that can be used for sending different types of signal through the transmission media for efficient communication, and also we shall discuss about the data encryption techniques, which is used for secrecy purpose or for the purpose of security, and various types of transmission services has a priority, grade of service and security. So, all these issues will be discussed in detail, particularly in the context of data communication through the internet. And by now you must have realized that the data communication is not a very simple technique. It will involve a number of very complex techniques, and we have already mentioned about a number of techniques, and obviously we shall see that it becomes a very complex thing. So, in such a case, whenever we have to deal with a very complex system, normally we use a layered approach. Layered approach is essentially a divide and conquer approach, where a complex problem is divided into a number of simple problems, and that each of these simple problems is solved independently and individually, and that is being precisely used in layered architecture. So, data communication, for the purpose of data communication, we have to use layered approach, and in fact the next lecture that we shall give is the layered on layered architecture, where we shall discuss about why layered approach is used, and what is layered approach, and the basic principles of layered approach, and how various layers, for example, a system is divided into a number of layers, and each of these layers is responsible for performing different functions. And obviously questions will arise how these layers interact with each other. So, in that context we shall discuss about layers and interfaces, and we shall see the various functionalities that is being provided, which can be hardware, software, or a combination of them, which is known as entity, and how various protocols are essentially agreed upon rules and conventions that is being used for communication, and how these protocols are used in a layered architecture. And in the context of layered architecture, we have to discuss about services and service access points, the types of services, service primitives, and particularly we shall discuss about the ISO's OSI reference model. International Standards Organization has proposed a open system interconnection reference model, which is essentially a framework of standard, and that is being widely followed. So, in the next lecture we shall discuss about the ISO's OSI reference model, and the functions of different layers will be considered. Layers used in OSI model will be discussed in detail. So, to summarize, let us discuss about give you some idea about the lecture sequence. First lecture that is being on now is essentially the introduction course outline, that is this lecture. Then we shall discuss about the layered architecture. Third will be, it will not be layered architecture, third will be essentially data and signal. Then the fourth lecture will be on transmission impairments and channel capacity. Then the fifth lecture will be on guided transmission media such as twisted pair, coaxial cable and optical fiber, and the unguided media will be covered in 6th lecture, and there we shall discuss about those radio, then your then the very other techniques that I have mentioned, unguided media or wireless communication techniques. We shall discuss in detail in the unguided media. Then transmission of digital signal will be covered in 7th and 8th lectures. That is essentially the encoding techniques that I mentioned, those unipolar, polar and bipolar techniques that is being used for converting digital and analog data into digital signal. So, this will be covered in these 2 lectures, 7th and 8th lecture, and 9th and 10th lecture will cover transmission of analog signal. That means how the digital and analog data is converted not in digital form, but in analog form by using different analog modulation techniques such as amplitude modulation, phase modulation and frequency modulation, when it converts analog data to analog signal, and also the ASK, amplitude shift keying, frequency shift keying and phase shift keying used for converting digital data to analog signal. And we shall discuss various multiplexing techniques in lecture 11, where we shall discuss about the time division multiplexing, frequency division multiplexing, and in the context of TDM, as I mentioned, we shall discuss about synchronous TDM and asynchronous TDM, and in the context of FDM we shall also discuss about the wavelength division multiplexing. Then lecture 12 will cover the telephone system and DSL technology, which are essentially the applications of multiplexing. Lecture 13 will cover cable modem and SONET. Lecture 15 will cover interfacing to the media. Then lecture 15 will cover various error detection techniques and error correction techniques by using Hamming code, and flow control or error control techniques will be covered in lecture number 16, where we shall discuss about stop and wait, flow control, go back in ARQ techniques. So, various ARQ techniques and flow control techniques will be covered in lecture 16, and data link control, particularly that HDLC, will be covered in detail in lecture number 17. Then lecture number 18 will cover the switching techniques such as circuit switching, and lecture number 19 will cover packet switching, various characteristics and features of packet switching. Lecture number 20 will cover routing in packet switching networks. As I mentioned, we have to use routing technique whenever we send packets through packet switching networks. Then congestion that can happen in packet switching networks will be discussed in lecture number 21. And lecture number 22 will cover the wide area network based on networks based on X.25 and frame relay. Lecture 23 will cover ATM, the asynchronous transmission mode, and in lecture 24 to 25 we shall discuss about the medium access control techniques such as contention based, then token passing based, reservation based. All these techniques will be covered in lecture number 24 to 25, and then in the remaining lectures we shall discuss about cellular telephone network, satellite network, various local area network including high speed local area network and wireless local area network, and we shall discuss about the internet and internet networking techniques. We shall also discuss about the multimedia communication, and where we have to use the compression and decompression techniques, and we shall discuss about the security in communication, where we shall discuss about encryption techniques and encryption and decryption, firewall and other techniques that are being used. So, this is in nutshell which will be covered in this lecture. So, with this we come to the end of today's lecture, the first lecture. Thank you.